Good morning, all. Welcome back after the weekend. I've just been speaking to some people in the live chat. I do apologise, but this lesson will be about 10-15 minutes rather than the normal 25 minutes long. There's nothing to worry about, but my wife has been advised to get to hospital and she's 38 weeks pregnant, so we are going to go straight after this. She's just getting some bits together and we're having a warm bath just to ease herself a little bit. So I'm going to rush through the things I was going to do with you today. Apologies for the late notice and the 11 o'clock and 12 o'clock ones. I'm afraid will have to be postponed today. If I've put a little message on YouTube, but if I'm sure Alicia is able to turn up to the 11 o'clock one and just advise people in the live chat why it's not going ahead and the fact that it's been postponed, that would be very helpful. So very quickly. So the first things we need to do before we learn about anything about to do with ratios is we need to go straight to here. Because it's Iona's birthday today. Happy birthday, Iona. So if everyone can wish Iona a happy birthday in the live chat, that would be fantastic. Let everyone know. And I think it's very important that we celebrate the happy day for Iona. So congratulations on your birthday. I believe she's 29 years old. I don't know. I think maybe 8, maybe 9. I don't know. But happy birthday, Iona. So here's a little puzzle for you while I'm saying some good mornings. Good morning to Vera. Good morning to Ellis. Good morning, Iona. Good morning, Amber. Good morning, Murray Minecraft. Good morning, Poon Pawar. Sidi. Good morning, Josh. Sorry. Good morning, Adeline Chung. Good morning, Debbie. Good morning, Charlena. Good morning, Grace. Good morning, Emily Rivers. Good morning, JJ Games. Good morning, Alexandra and Kira. Good morning, Anna Grace. Good morning, Tom and Tilly. Good morning, Ollie and Alex. Good morning, Alvi. We've got one person thinks the answer is 16. I disagree, Vera. I don't think the answer is 16. Maybe it is because there's 2 6s. I haven't even thought about the fact there's 2 6s. That changes it, doesn't it? Good point. So, that means that 1966 is the same as 1966. That's very clever. Because I think it's 4 times 3 times 2, which is 4 times 3 times 2 is 24. But, as you correctly say, in every single one of the ones where one of those, the 6s can be swapped round and it looks the same. So therefore I think we have to halve it. So I think the answer is 12. So well done, Ellis, for saying that there's 24 combinations. But because 1966 and 1966 is the same combination, I think we have to go for 12 as our answer, which is what Amber said. Although some people are suggesting 16, so I'm interested to see what those 16 different combinations are. I think normally, because there's 4 different numbers that can go first, then 3 numbers that can go second, then 2 numbers that can go third, and then 1 number left that can go last. But as we said, that the 6s can be in both places, so 12. Okay, so we're looking at ratios today, and I'm going to focus mainly on marbles. And we're going to race through ratio. We're going to ratio. Sure. I don't know why I put a picture of a black bit on the screen. I do apologise for that. Hopefully you can see me. I don't know whether I'm there or not. Hello. Yeah, I'm off to the side today. I've fallen over and I can't get up. There I am. I'm moving on up. So ratio is used when we are trying to compare 2 things. You can't have a ratio with one item because you've got to have a ratio of things to things, which is why I've suggested having some things. I'm going to focus on the ratio of marbles, and I'll show you what I mean using these marbles. So in these marbles, there are green, red, and blue marbles. There are therefore 3 different ratios we can find. In fact, there's 4. We could do the ratio of blue to red, we could do the ratio of blue to green, and we could do the ratio of red to green. But we could also do a ratio involving all three of them, which is red to blue to green. Now, the simplest way we do this is we just say how many of each one there are. So if we're doing blue to green, there are 4 blues and 6 green. So we would just write 4 to 6. And that's quite straightforward, just going 4 to 6. We can cope with that. However, the thing I wanted to draw people's attention to is that 4 to 6 is not the finished answer. Because if we look at this next page, here we have a different one, and you can see blue to red, quite straightforward, is 4 to 8. However, if I do this and move them over like that, can we all see that this 4 to 8 could be split into 2 lines? The top line is 2 to 4, and the bottom line is 2 to 4. And that means we can simplify it, and I think we can even simplify it further. Let me show you in my whiteboard what I'm talking about. So we had, first of all, 4 to 8. We had 1, 2, 3, 4, and we'll change colour. I'm changing from red and blue to purple and green. I hope that's okay with everyone, because I'm trying to do it quickly. So what I did is split it in a line, and then we noticed that because they're the same on each side, we can do this. This must be the same as 2 to 4. But also, I could have written it down as 1, 2, 3, 4. 1, 2, 1, 2, 1, 2. Hopefully you all agree that's 4 to 8 as well. And actually, I could break this down into 4 groups, which are all the same. So therefore, it must go to 1 to 2. And the way we do that is we look at both sides and we divide by the same thing on both sides. So on this one, I can divide them by 2. If I'm allowed to do them both, if I can do the same to both sides, it will simplify. So we're just looking for a times table that they're both in. This one also divides by 2. Please note, I could have gone straight there. I could have gone all the way from 8 to 2 by dividing by 4, and I could have gone all the way from 4 to 1 by dividing by 4. So when you're simplifying ratios, you're just looking for numbers that are in both times tables. Let me show you another one. If I have this one, and I'm not going to draw them out now, I'm going to just write the numbers. If I had 12 to 21, I'm going to divide by 3 because they're both in the 3 times table. That makes 4 to 7 because they're both in the 3 times table. So 12 divided by 3 is 4, 21 divided by 3 is 7. So when you're looking to do it, you're looking for the times tables they are both in. That we would call a simplified ratio. You're just looking to find numbers that they both divide by, but they mean the same thing. Those 12 to 21 is the same ratio. They are not different ratios. And some people struggle with this idea as 4 to 7. They're the same ratio because all I'm saying is I can put 4 with 7, 4 with 7, and 4 with 7, and altogether I would have 12 to 21. They're the same relationship between the red ones and the blue ones, or the green ones and the purple ones. Ratios describe relationships between the different marbles, or between different items. Therefore, if they're describing relationships, we're just going to keep it as we've done there. Okay, heading back over into the thing. I'm sorry if I'm being quite rushed today. You can imagine I've got things on my mind right now, I'm going to get myself to hospital as quick as I can to look after my wife. So, unit ratios. We've got a unit ratio is where one of the numbers is 1. But to do unit ratios, sometimes you have to do you have to be able to do it so that it's not a whole number. Normally we like to keep ratios as whole numbers. Okay? So normally we are trying to keep both numbers as whole numbers. But sometimes if we want a unit ratio, we don't. Unit ratios, I want a 1, and it's normally the first number, So we want to make a 1. So in order to do that, I am going to do the following. I am going to divide them both by 5. The way to get 5 to become a 1 is to divide by 5. So I'm going to divide it by 5. But 24 doesn't divide nicely. But if we use a calculator or if we work it out using decimals, we would find that it's 1 to 4.8. That is called a unit ratio because it has got a 1 at the front. Okay, Lily, what question? Have you got a question for me? You need to ask a question rather than just say I'm confused. It's absolutely fine to be confused. You are allowed to be confused. That's absolutely fantastic. It means you're trying to understand it. But try and put it as a question if at all possible. Ellis, you're absolutely right. We could call this 4 4/5 as well if you don't like that. Iona, which bit do you not understand? Can you try and turn it into a question? I'm always happy to answer questions, and same with Patrick. But you need to say a question rather than just saying I can't do it or what do you mean. You can't just say I can't understand. Okay, it's okay to be stuck on this, but you need to ask me questions. Let me go back into my whiteboard, and I'll do another one. But we'll come away from the unit ratios for a second, just to make sure people understand. A ratio is just comparing some things. So let's say I've got a ratio of 10 to 25. All this means, all those people saying I don't understand, Patrick, you can't say how do I work it out. It is not a thing. You need to be more specific. You need to explain what it is you need to work out. This is 10 to 25. This means there are 10 items. Let's say little marbles. I'm using marbles. It could be any items. It could be baked beans that are red and kidney beans. It could be anything you're comparing. I'm going to put 25 items over here. 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All this is saying there are 10 purples to 25 greens. So I put a green and a purple up there. 10 purples to 25 greens. It's the relationship between these two piles of things. But we can simplify that relationship by remembering, are they both in the same times table? So 5, 10, 15, 20, 25. They are both in the 5 times table. Therefore, we're going to divide by 5 and divide by 5, leaving 2 to 5, because we have found out numbers that they're both in the same times table. We divide by that number on both sides. This is called a simplified fraction. This is the answer. I hate the phrase the answer. I hate the idea of the answer because maths is not about the answers. Unfortunately, we seem to accidentally learn at school that the answer is what we're trying to do. We're not. We're trying to understand what a ratio is today. We're not trying to get answers. We're trying to understand what a ratio is and how to simplify it. This is in its simplest form because it can't go any smaller. 2 and 5 aren't in the same times table, except for maybe the 1s, but we don't divide by 1 because it doesn't change it. Okay, Emily, is that correct? You did get 2 to 5, so you understand that? Okay, Patrick, thank you very much, Patrick, for letting me know you get it now. That's really helpful. Emily, you need to tell us how you're confused. Okay, excellent. Look, the people telling me their questions are really, really powerful. Thank you very, very much. Okay, so I'm going to dip back to my PowerPoint. And on my PowerPoint, it says that what I was talking about was unit ratios when they don't go nicely. So if they don't go nicely, we need to get it so that 1 is the first number. That's what a unit ratio is. It just means 1 is the first number. And to do so, you divide both bits by the first number. So we divide both bits by 5. You are allowed a calculator, or as Ellis showed you, you can do it as a fraction. And you get 1 to 4.8. So this one would be called a unit ratio because it's 1 to 4.8. Okay, remember you can always rewind the video and watch it again. You're not expected to learn first time, and if you get confused, it's absolutely fine to be confused. That's absolutely fine. You're not in any trouble for being confused. So that was very, very fast. I was going to spend a bit more longer on it today, but as I've already explained, you understand the reasons why I've whizzed through it. If you've got more questions, please do explain. Natasha, it's 4.8 because 24 divided by 5 is 4.8. Okay. Well done, those people, for answering good questions. Lily, did it make sense to you eventually? I didn't catch up with whether you whether you made sense. I hope it did. You need to tell me what you mean by they're too hard. You need to tell me what that means, because I don't know what you mean by they're too hard. I'm always going to happily help you, but you need to tell me which bit's too hard, which question you're stuck on. If you tell me what question you're stuck on, myself and the other people in the chat are very kind and we will try and help you with it. But you can't just say they're too hard because we don't know which bit you're confused on. Let me just do one more with you and we'll look at it together, okay? So, we've got 4 goes with 6. All this means is I've got 4 aeroplanes. Don't know why I've chosen aeroplanes, because they take ages to draw. That was stupid. 4 aeroplanes. Worst aeroplanes in the world. I think I need something simpler to go with against these aeroplanes. So we've got 4 aeroplanes and 6 cars. Of course, I've done cars. They're nice and long as well. So the relationship between the number of cars and the number of aeroplanes is 4 to 6. Lily, are you with us so far? Can you tell me whether this makes sense? Why it's 4 to 6? Because there's no point me moving on if that doesn't make sense. Oh, I'm in the way. Oh, thank you very much for telling me we can't see the whiteboard. I do apologise. Sorry for that. So, Lily, do you understand why that's 4 to 6 with those pictures? Hopefully you can see it now. Fantastic. I'm glad Nan's helping. That's really helpful. Jan, does Lily understand that that's 4 to 6 at the moment? Now, 4 and 6 are in the 2 times table. 2, 4, 6, 8, 10. That's where they're friends. So because they're in the 2 times table, we're going to divide them both by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So the simplified ratio is 2 to 3. And we can see that as a picture because those 2 can go with those 3 and those 2 can go with those 3. So every 2 has got 3 that go with them. Hopefully that's helpful. We are going to quickly whiz back to the studio, which I will insist on calling a studio because you know I like to call it a studio. Here's your work for today. There's some simplifying ratios in the description below the video. You've also got a Taskmaster challenge for this week. Everyone has the same one. Make a friendly note, no threatening letters, out of cutting each letter from the newspaper. You're making a note of however you want to do. Write a letter to someone, write a note to Mr. Harris, write a note to each other, describe something, maybe write a nice note to a mum or a dad or a carer or a nan. But you have to try and use a newspaper or magazine so every single letter has to be cut out separately and glued to make the phrase. It's like a ransom note, but a friendly ransom note. That's the challenge for today. Okay. And so you've got the simplifying ratios worksheets and the challenging things. I've been Mr. Harris. You haven't. I really appreciate you all being here. I'm sorry that I'm going to be cancelling the net one at 11 o'clock. But hopefully, if all goes according to plan, I'll be here tomorrow or I'll let people know if I'm not. Thank you so much for joining me. You are all amazing. I will speak to you soon.